We've talked a lot about solving for missing sides and angles of right triangles. So today we're going to look at how this can apply to real world situations. So there's two definitions that are going to be really important for you to understand: the angle of elevation and the angle of depression. So the angle of elevation denotes an angle that is formed above the horizontal. So think about a horizontal line. If you had a horizontal line this way, the angle that is created using that horizontal but is above it, this is considered to be that angle of elevation. Versus if we're talking about the angle of depression, this is the angle that is formed below the horizontal. So if you have a horizontal line, the angle that is created with that horizontal but is below it is considered to be your angle of depression. So if we talk about an example, it says the angle of elevation from my car parked in the school parking lot to the top of the building is 35 degrees. So let's say, and you're going to see my awesome drawing skills here. Let's say this is my car. I know it's a great car. The angle of elevation, so it has to go from a horizontal. So let's say this is the horizontal line. This is representing the parking lot over here to the building. My angle of elevation is from that horizontal up to the top of the building. Ooh, that is a rough line. I could make that a little bit straighter maybe. So up to the top of the building. This is the angle of elevation right here. It has horizontal line as one of its sides, and then the angle is above it. So this angle right here, they're saying is 35 degrees. Another example, the angle of depression from the top of a lighthouse to a boat is 48 degrees. So let's say we have some water over here, and here is this awesome boat, little flag there, and you have a lighthouse over here, and usually there's a little spot up here. Maybe it looks something like that, okay? So the angle of depression from the top of the lighthouse. So we're talking about looking from the top of the lighthouse down to this boat. So the angle of depression has to come down from a horizontal. So I know a lot of times people think, oh, well, this is the angle right here between this side and then the horizontal from the water, but it's from the top of the lighthouse. So the angle of depression is from the top here. So it's like you would want to draw in your horizontal line here. If you were standing at the lighthouse looking straight out, you would have this line of sight, but then when you look down from that horizontal, this is actually where the 48 degrees would go. So it has to always be from a horizontal. So you can draw that horizontal line in that you need to have in your picture. So let's look at some examples of angles of depression and angles of elevation. So I have different numbers here in the picture, and we want to just describe what each of these angles are telling us. So I have some birds here, and I have a ship. So this angle number one right here, I can see here's the horizontal. It is under the horizontal. So angle one is going to be an angle of depression from the birds to the ship. So that would be how I would describe angle one. It's an angle of depression from the birds to the ship. Versus angle two, I can see that its horizontal is here and the angle is above that horizontal. So this is an angle of elevation, and it's from the perspective of someone on the ship looking at the birds. So angle two would be an angle of elevation from the ship to the birds. Angle three starts at the ship, but here's the horizontal side. The angle is underneath that. So this is going to be an angle of depression, and this is from the perspective of someone on the ship looking at a submarine, which is below the water there. So angle number three is an angle of depression from the ship to the submarine. And finally, angle number four, I can see here's the horizontal. It is coming up from the horizontal. So the angle is above the horizontal, which means this is an angle of elevation. And this is from the perspective of someone looking from the submarine to the ship. So that would be an angle of elevation from the sub to the ship. Angles 5, 6, 7, and 8 over here, I can see the first angle 5. Here is the horizontal. The angle is below the horizontal. So this would be an angle of depression, and it's from the perspective of maybe the pilot of the plane looking down at the man. So the angle of the depression from the plane to the person. Number 6 is here's the horizontal line that is associated with angle 6. The angle is above that horizontal. So this would be the angle of elevation from the man looking up to the plane. Number 7, again, is from the man, but this angle, here's your horizontal, it's below the horizontal. So this would be an angle of depression for the man looking down to the boat. And number 8 is from the perspective down here from the boat, looking up to the person, looking up to the man. So here's the horizontal, the angle is above the horizontal, so this would be an angle of elevation from the boat up to the man. So how is this going to help us, and how does this tie into trigonometry the way that we've been using this? Well, we're going to draw some examples, and again, I just kind of highlighted that the angle of elevation is when you're looking up. So here's your horizontal, the angle of elevation is above it. We're going to draw and label a diagram and solve for the missing part. And in any of these questions, you can round your answers to the nearest 10th. So I have Casey sights the top of an 84-foot tall lighthouse at an angle of elevation of 58 degrees. If Casey is 6 feet tall, how far is he standing from the base of the lighthouse? So that's very similar to this situation right here. So just to kind of speed things up, I'm actually going to copy this right down here so that I can do some labeling here. So what we said was that our person was 6 feet tall. So this length from here to here is 6 feet. Whereas the lighthouse, so from here all the way down to the ground, that's 84 feet. The angle of elevation, so it says Casey sights or sees the top of the 84-foot tall lighthouse at an angle of elevation of 58 degrees. So if Casey were just looking straight out, that would just be this horizontal line. But Casey looks up to the top of the lighthouse, and this angle of elevation right here is 58 degrees. So hopefully you can see that this is really the triangle that we're working with is right here. You can see it drawn in. So if I drew that off to the side over here, here's my right angle, we would be able to say that this angle is 58 degrees. And it looks like we want to figure out how far is he standing from the base of the lighthouse. So here's my angle. This is the side that we're looking for. So I need to know what is this side over here. Well, it's not 84 feet because 84 is the entire length of the lighthouse. So it's 84 minus the 6 feet. Clearly, this is not drawn to scale, but minus the 6 feet, which is Casey's height. So 84 minus 6, this side over here is actually 78 feet. And now you can see that we have a right triangle where one angle, one of the acute angles, and one of the legs is given, and we're solving for the other leg. So based on the position of this angle, this side is the opposite side. This side is the adjacent side that we're looking for. So this is going to be a tangent equation. So I'm going to write it over here just because I have some room. So the tangent of our angle 58 equals opposite over adjacent, so 78 over x, and then we want to solve for x. So we're going to treat this like a proportion where our cross products are equal. So 1 times 78 should equal the other cross product, x times the tangent of 58. So in order to isolate x, now we need to divide both sides by the tangent of 58. So using your calculator, you're going to type in 78 divided by the tangent of 58, and we should get that x is approximately 48.7 feet. So that means that Casey is standing 48.7 feet away from the lighthouse. Let's look at a second example. The angle of elevation from a kicker's foot on the football field to the top of the goalpost bars is 17 degrees. So picture this. If you have someone standing down here on the field, right? Here's my kicker. They're standing 131 feet away from the goalpost. So this distance all the way over to our goalpost, right? Here's our goalpost, is 131 feet. So the angle of elevation from the foot up to the top of the goalpost bars is 17 degrees. So this angle right in here is 17 degrees. It's up from the horizontal. It had to include the horizontal and it goes above it. So I knew it was this angle here. how tall is the goalpost? So really, I'm looking for this side of the triangle, which I can call x. So I can see in this situation that from my angle, I have the opposite side and the adjacent side. So again, this is going to be a tangent problem. So we would say the tangent of 17 degrees equals x over 131. So again, setting cross products equal, 1 times x is x. That equals the other cross product, which is 131 times the tangent of 17. And when you type that in your calculator, and your calculator is in degrees, we could say that x is about 40.1 feet. And you can put approximately there as well. So that means that the goalpost is about 40.1 feet tall. Leah's mom is standing at the bottom of the slide at the playground, waiting for Leah to slide down. If the angle of elevation from the bottom of the slide to the top is 46 degrees, and the slide has a vertical height of 9 feet, find the length of the slide. So hopefully you can picture this. Let's say that maybe here's the ladder of the slide, and the slide goes down like this, right? Here's the ground where the base of the ladder is, and here's over here the base of the actual slide. So it says the slide has a vertical height of 9 feet. So it's 9 feet above the ground over here. This is where my right angle is. And then it says the angle of elevation from the bottom of the slide to the top. So here's the bottom of the slide. I can see the horizontal. So the angle of elevation is above that horizontal. So this angle right here is 46 degrees. So if you're looking from the bottom of the slide, basically up to the top of the slide here. We want to know the length of the slide, which is right here. So this is the side of the triangle that we're looking for. So in this problem, for the location of my angle 46 degrees, this side over here is the opposite, and this side is the hypotenuse. So I would say here, in this case, we have the sine. So the sine of 46 degrees equals opposite 9 over hypotenuse x. So we want to solve this proportion. 1 times 9 is 9. That equals the other cross product, x times the sine of 46. So to isolate x, we would take 9 and divide by the sine of 46. So typing that in our calculator, we get approximately 12.5 feet, which makes sense. We're expecting something to be longer than 9 feet here since we were looking for the hypotenuse of the triangle. I'm going to challenge you to try the next one, see if you can figure out the setup of your picture. So a dog is standing 5 feet from the base of a tree. So if you're not very artistic, you can do things like this. Dog, right? This point represents the dog. And maybe your tree, you don't really want to draw a tree, but you could say, okay, here's the ground and here's your tree. Or if you want to get fancy, you can make it look like a tree. It's up to you how fancy you want to make it. But the dog is standing 5 feet from the base of the tree. So here's the dog, the base of the tree. That means this distance here is 5 feet. And the dog is looking up at a cat that has climbed 16 feet up in the tree. So if the cat is located right here, this distance is 16 feet. What is the angle of elevation from the point the dog is standing on the ground to the cat? So from the dog, the angle of elevation comes up from this horizontal. So if I were to draw in this triangle up from the horizontal here, this is the angle that they're looking for. This is the angle of elevation. So we're solving for the angle in this case. So the opposite side and the adjacent side are what we're using. So this is going to be a tangent problem. The tangent of our angle x equals opposite 16 over adjacent 5. So to isolate x, we're going to take the inverse tangent of both sides. So the inverse tangent of 16 over 5 will isolate x. And using your calculator, you would get that x is approximately 72.6 degrees. And that would be your final answer. I'm going to pause this video here. I want you to watch the next video for the second half of your notes.